Hi, welcome. We're going to go over our foldables. So these are the properties of a quadrilateral, and we're going to start with the most popular one, Mr. Square. So here's kind of what I'm looking for. So just so you know, Mr. Square shares all the properties that parallelograms have, which we're going to review here in a minute. They share all the properties of a rectangle and a rhombus, and by definition, a square are four congruent sides and four right angles. So if we look at this picture, this means this side matches this side matches this side, and I didn't make two marks here because all four sides are equal. A 90-degree angle, they all have 90, 90, 90. Interestingly enough, that caret means that that's parallel. We also know two carets. This line is parallel to that line. And I think it should make sense that this diagonal got cut in half, and these are all equal as well. And also these diagonals meet at a 90. So there's a lot of things on this picture we're going to talk about in the next chapter. Pretty cool stuff. Okay, so that's what's going to go in your square box. Let's go to rhombus. So in our rhombus box, we know that Mr. Square happens to be a rhombus. So you might be thinking, why would that be? Well, a rhombus by definition is four congruent sides. So you see why Mr. Square has four congruent sides. A rhombus takes on all the properties of a parallelogram. Its diagonals are perpendicular. The diagonals bisect opposite angles. Pretty neat. And again, the definition is four equal sides. So let's zoom in on our picture here. These symbols, the top matches the bottom and the left matches the right. So all four sides of a rhombus are equal. This is equal to this, and that length is equal to that. This is parallel to that. This is parallel to that. And these angles got cut in half. They were bisected. Lots of stuff going on in one little shape. Okay. So we're done with this side. Let's go to this side. Okay. So let's talk about our kite. What are we looking for there? A kite is a little bit different. We fold it in vertically, we would notice that the center of our kite, the diagonals meet at a 90. These angles here and here are equal. Like this whole angle on the top and the whole angle on the bottom are equal. This length is equal to this length, and that length is equal to that length. So let's see what that would look like. Diagonals are perpendicular. Yep, one pair of opposite angles are congruent, the top and the bottom. The definition is two pairs of congruent consecutive sides, meaning this side is next to this side and they're equal length. This side and this side are next to each other and they're equal length. That's what we need for a kite. Cool. Let's talk about our rectangle. A rectangle has these properties. By definition, they've got four right angles, so make sure you put four boxes there in the corner. Their diagonals are congruent, so all four of these diagonals, the long one, and the four little short ones are all equal. They also are parallelograms, so the left is parallel to the right, and the top is parallel to the bottom, and those opposite sides are congruent as well, so make sure you get these marks. Cool. Almost done. Let's look at the parallelogram. So we've been talking about a parallelogram, so what should we write down? You know, it's a popular shape. There's quite a lot we can write down. We'll zoom in on the symbols. Notice the length of the top matches the length on the bottom. The length on the side matches the length on the side. This diagonal length matches this one. This one matches this one. They're parallel to each other. They're parallel to each other. That's why we call them parallelograms. These angles are equal. These big angles are equal. And this is basically what everything I said in symbols, now I'm saying in words. Diagonals bisect each other. Consecutive angles are supplementary. opposite angles are congruent, opposite sides are congruent, and by definition, we just need these opposite sides to be parallel. Because their opposite sides are parallel, oh, there's the bell. Because they're parallel, all of these properties are created in our picture. Last but not least, our pal, Mr. Trapezoid. So when we think of a trapezoid, we think of the shape of our desk. And so let's think about some of the things that go on in a trapezoid. Here it is. Okay. So a trapezoid generically just means one pair. So the top and the bottom are parallel. These are not parallel. See how they're getting ready? If I continued to draw a line, they would meet. Now a special kind of trapezoid is an isosceles trapezoid. So let's zoom in on those symbols. Looks like the left is equal to the right. The top and bottom are not equal. This one's long or shorter than the bottom one, isn't it? This one's shorter than this bottom one's really long. But they're parallel, so that caret means they're parallel. These are equal length, and those are equal length. These characteristics only happen if it's isosceles. So to be isosceles, I need one pair of parallel sides, and the diagonals have to be congruent, and by definition, to be a special kind of trapezoid, you have to have congruent legs and congruent base angles. So that angle has to equal that angle, and those sides have to be equal. Notice up here, that's not happening in my regular old generic trapezoid. Thanks for joining us. See you next time.